Hello everyone, this is Jahnavi. I am from third year CSCP. Now I am going to discuss with you about putting probability to the test hypothesis in statistics. Now let us see the introduction part. Today we will be discussing one of the most important concepts in probability and statistics, hypothesis testing. At its core, hypothesis testing is all about putting informed decisions based on data. It helps us to determine whether our assumptions about a population are correct or not. In this presentation, we will cover everything you need to know about hypothesis testing, from a defining what a hypothesis is to understanding p-values and type 1 and type 2 errors. By the end of this session, we will have a solid understanding of how hypothesis testing works and how to apply it in real life situations. Now let us see what is hypothesis. A hypothesis is a proposed explanation for an observation or phenomena. It is an educated guess that can be tested through experimentation and analysis. In probability and statistics, hypotheses are used to make predictions about the relationship between variables and to test whether these predictions are supported by the data. Hypotheses play a crucial role in scientific research because they provide a framework for testing ideas and theories. They allow researchers to make predictions about the world and to determine whether these predictions are accurate or not. Without hypothesis, scientific inquiry would be aimless and unproductive. Now let us see what is null and alternative hypothesis. In hypothesis testing, the null hypothesis is a statement that there is no significant difference between two populations or variables. Alternative hypothesis is the opposite of the null hypothesis and suggests that there is a significant difference between the two populations or variables. For example, let us say we want to test whether a new drug is effective in treating a certain condition. The null hypothesis would be that the drug has no effect, while the alternative hypothesis would be that the drug does have an effect. To formulate a good hypothesis, it is important to be clear and specific about what you are testing and how you will measure the results. Now let us see significance level and p-values. Significance level is a term used in hypothesis testing to determine the likelihood of rejecting a null hypothesis. It is also known as alpha and is usually set at 0.05 or 0.01. A p-value, on the other hand, is the probability that the observed results are due to chance alone. To interpret the results of hypothesis testing, it is important to compare the p-value to the significance level. If the p-value is less than or equal to the significance level, the null hypothesis is rejected. If the p-value is greater than the significance level, then the null hypothesis cannot be rejected. See what are type 1 and type 2 errors. Type 1 and type 2 errors are two types of mistakes that can occur in hypothesis testing. A type 1 error occurs when a true null hypothesis is rejected, while a type 2 error occurs when a false null hypothesis is rejected. In other words, a type 1 error is a false positive, while a type 2 error is a false negative. For example, if we reject the null hypothesis that a coin is fair when it actually is, we have made a type 1 error. If we fail to reject the null hypothesis that a coin is fair when it actually is not, we have made a type 2 error. To minimize the risk of making these errors, it is important to choose an appropriate significance level. Conduct a powerful analysis to determine the sample size needed for the study and use reliable statistical methods. It is also important to clearly define the null and alternative hypothesis and to report all relevant statistics and confidence intervals. By taking these steps, researchers can ensure that their results are accurate and reliable. Let us see the conclusion. In conclusion, hypothesis testing is an important tool in probability and statistics that allows us to make informed decisions based on data. By formulating clear and testable hypotheses, setting appropriate significance levels, and interpreting p-values correctly, we can minimize the risk of making type 1 and type 2 errors and draw valid conclusions from our experiments. When applying hypothesis testing in real life situations, it is important to keep in mind the context and limitations of the data. Always be aware of potential confounding factors and sources of bias, and use appropriate statistical methods to account for them. Additionally, consider the practical implications of your results and communicate them clearly and effectively to stakeholders.